12:11 with your host, me, Dr. White. I'll say it tomorrow, but I'll say it now also. I hope you all have a wonderful Thanksgiving holiday. I hope it's safe. I'm not going anywhere. Normally I get together with family. No, we're not doing that because one, I don't think I have the virus to give to someone else, but I might. And I don't want to get it from someone else. So we're all playing it safe and we'll be using Zoom. Uh, Tomorrow I'll do some shopping. No, I'm not going to make a turkey. Sometimes I do for myself, but I'm not. I'll make some other traditional things. Plus, I hope they have on sale. It's time for Dr. White to gross you out. Dr. White loves, since I was a little kid, my mother used to make them, turkey gizzards. If you've never had turkey gizzards, you're missing one of the great pleasures in life. You're probably all going, but I love them. And they're on sale usually right around Thanksgiving. So I stock up and cook them and put in my freezer. Enough of the good things in life. All right, important announcements. One, there's no lecture Thursday. It's Thanksgiving and the school's closed. Two, because Wednesday night, most of you aren't going to be thinking about school and chemistry, I've moved my Wednesday night office hour to Tuesday night. Same Zoom address, but just now on Tuesday night. So this way you won't be cheated out of any time with Dr. White in case you need it. All right. Next, tomorrow we're going to have our normal lecture from 10 to about 11:45. Tomorrow, I'll go through chapter 15, that's chemical equilibrium with Le Chatelier's principle, problem set tomorrow. I definitely hope you come. If not, watch the video. And anything else? Oh, the lab that I talked about a week or so ago, last Tuesday, is due tomorrow. And we'll also go through a lab tomorrow since we don't have class on Thursday. But if you can't come, that will all be on the video. And it's commercial free. Well, maybe I'll pop in a commercial for the Save Dr. White Foundation. Don't forget to do that. And finally, one last or two last announcements. I got an email that I guess the COD has sent out your online evaluations for this class. And if you'd like to, please fill it out. Also, I would like to ask at this time or sometime next week or so, if you really like what I did, go to ratemyprofessor.com and let them know. Or if you really didn't like what I did, go to ratemyprofessor.com and let them know, other students. The other thing I would say, if you really, really like what I did, send an email to the Board of Trustees of COD and copy the president. And if you really, really didn't like what I did, send an email to the Board of Trustees and copy the president. Now, I'll send out next day or two an email with those email addresses. My only advice, if you do send the Board of Trustees an email about how I performed, good or bad, hopefully good, but who knows, that's your opinion. Write it, let it sit a day or two and review it, and then send it. Don't just pound out something and send it immediately. Let it sit for a day or two and age and reread it. Anything important I ever write, I do that for myself. Blueberry tea, the best. Also, I love my vanilla almond from the Republic tea. I see I'm not the only tea drinker, but oh, more tea drinkers. If you like tea, buy it from the Republic tea. I've been buying from them for over 25 years. I just got a big order in before the holiday rush, and I buy in bulk. So the vanilla almond and the blueberry tea I got in 250 tea bag bulk. It's cheaper too. It'll last for a long, long time. All right. Coming up soon will be test number 4. I'll talk more about that next week. Also, don't forget, there's a deadline. I think it's a week from this Thursday is test number 4. So I'll put out before the end of the week, Thursday or Friday or Saturday, the points breakdown. Test number 4 will be on equilibrium with Chatter's principle in this chapter, which I'll finish this week, acids and bases. And next Tuesday, I'll go through the acids and bases problem set. Isn't it nice we're on track? All right, now I got all that out of the way. Let's get back to acids and bases. Everybody see Brønsted-Lowry acid and base theory on the screen? Thank you. All right, quick review. You should know Brønsted-Lowry acid, proton donor, proton H+. Brønsted-Lowry base, proton acceptor. I'll do it again because this is probably one of the most important chapters, if not the most important chapter this semester, especially for your daily life and your professional life. You should know a Brønsted-Lowry acid, or sometimes people just say acid because most people assume you're doing the Brønsted-Lowry acid definition, proton donor. Isn't it nice? I got the important stuff highlighted in red. And a Brønsted-Lowry base, proton acceptor. Now, I'll talk more about this today. Protons can react with water to give what's called the hydronium ion. And this is actually a covalent bond, 3 hydrogens, 1 oxygen, but it has a plus charge to it. I talked about conjugate base acid-base pairs, so let's move on. All right. Next couple of slides, click. I'm turning the switch. Will this be on a test? Off, but it's still something you should know about for your daily life. It won't be on the test, but it's still important information. When it comes to acids and bases, not all acids, not all bases are created equally. And we have the concept of a strong acid. And a strong acid is a substance that transfers nearly 100% or very nearly 100% of its protons to water. Oh, see equilibrium equation on board. Now, real quick, and this won't be on the test, but all halogen acids, HX, and here, X equals fluorine, chlorine, bromine, or iodine, the halogens. By the way, this X is what organic chemists use. They're all strong acids. It says except F, but it's a dangerous acid too. Nitric acid and sulfuric acid are very strong acids. When I say strong, you get it on your skin, it will destroy your skin and clothing too, and other things. Now, and if we have sulfuric acid and water, notice I have an equilibrium right here. And the forward to the right is a much larger arrow than the tiny little arrow to the left because the equilibrium. Now, something important, and this will not be on a test. Well, the equilibrium constant normally deals with the concentration of the products divided by the concentration of the starting materials. And you learned that last chapter. Now, there's a problem with this, and that is water. In any reaction, water is going to be a large number. That even small changes, it still is going to be a large number. So what chemists did is said, well, if that's a large number, let's have a special equilibrium constant we call Ka, A for acids, where we eliminate the concentration of water. And for strong acids, Ka is much greater than 1, really much greater, which means the equilibrium goes this way. And that's a strong acid. Now we have weak acids, and those say, oh, do you want my proton? No, I'm not going to give you that much because I'm a weak acid. And the most important weak acid is acetic acid. And again, switches off, but you should know acetic acid is in vinegar, and it's 5%, or I take that back, about 4% acetic acid and 96% water, and that's vinegar. Now, if acetic acid wasn't a weak acid and you had vinegar, it would destroy the inside of your mouth and probably kill you. But luckily it's weak. But even though it's a weak acid, we don't do it in Chem 1211, but when I've taught Chem 1212 and when I teach the equivalent Chem 170, which I will this spring, if you need organic chemistry, look at ECC. I'll be teaching it there. I no longer teach it at COD. I'm not going to go into that story. But pure acetic acid, which is called glacial acetic acid, it's still, even though a weak acid, you smell it, it will knock you right off your feet. It's that strong. But in vinegar, it's a very dilute solution. Oh my goodness, you know what a dilute solution means. See how dangerous I am? I've taught you all this chemistry, and hopefully it hasn't been that painful. Now, just like acids, you can have strong bases. Since I was playing around, everybody see strong bases on your screen? Thank you. All right. Now, most strong bases are mainly, for this class, hydroxides of group 1A or 2A, which are the alkali metals and the alkaline earth metals. Examples of strong bases, you should know this is a base, sodium hydroxide and potassium hydroxide. Also ammonia is a strong base. And here I have them again. Now, again, the equilibrium constant for a base equals a hydronium ion plus where M is a cation like sodium or potassium. And again, you remove the water. And when Kb, the basicity constant is greater, much greater than 1, it's a strong base. When Kb is less than 1, it's a weak base. Now, what's the most important weak base? Sodium bicarbonate. And hold on one second, I didn't shut off spell check. There you go, no squiggly red. And this is baking powder. And as you all know, baking powder is a weak base, or now you know, and you use it in cooking. If we're a strong base, well, if you used it in cooking, you'd be in serious problem, like in the hospital, but you don't. Now, the conjugate bases of strong acids are weak bases, but again, this is not going to be on the exam or the final. Switch is still off. You can have mono and di and triprotic. Protic means proton acids. A mono acid is an acid that transfers one proton during an acid-base reaction. A diprotic acid can transfer two protons, up to two protons in an acid-base reaction, and a triprotic up to three, and poly means many. That means it can do a lot of protons. Not all hydrogens in a molecule are acidic. See acetic acid. Now, switch is still off. If you take organic chemistry, this is the structure of acetic acid. If you notice, it has hydrogens here on the carbon and one hydrogen here on the oxygen. Well, it turns out the only thing that's acidic is this hydrogen. So if I react it with a base, proton transfer, and acetic acid is a monoprotic. Now, sulfuric acid, both of these are acidic. The first one is more acidic than the second one, but they still can be acidic. Again, switches off. All right, next couple of slides, I'm going to be covering probably the most important stuff I'll cover this whole semester for you. So everybody pay attention. If I had a dial and I could only go up to 10, I just turned it up to 1,000. That's how important the next couple slides are. Now, for any acid, and I've already covered this, I got ahead of myself. The acidity constant is this. And remember, we took off water, where HA is any acid, and it delivers a proton to water. That's why this has gone from 2 to 3 with a plus charge, and you get the anion of the acid there. Same thing for a base. I've already covered this. Now, I guess I got ahead of myself. Now I've turned the dial up to 1,000. Now, it turns out water, the stuff in this bottle, is amazing stuff. I mean, really amazing. Besides hydrogen bonding, water does something quite else that's amazing. And that is it can react with itself in the following reaction. Make sure. Quick check. Everybody see the association of water on the screen? Thank you. All right. Now, remember, the switch is on, really on. A small amount of water can interact with its other molecules to form ions. And this is called dissociation of water. Water can react with itself to form the hydronium ion, which I'll never ask what that is, and the hydroxide. And again, I won't ask on a test, but I'll use terminology today that H3O plus is called the hydronium ion. OH minus is called the hydroxide ion. Both are very important in our daily life. Tea break. Now, it turns out if we were to look at the, I'll write it down here, this equilibrium, the association of water, if I wrote the equilibrium constant, it would be H3O plus over hydroxide concentration minus over water. Yeah. Water times the concentration of water. Now, water is the largest amount and never changes. And here you got water squared, and this won't work. So what chemists said is, let's come out with a new constant and leave water off. And this is called the ionization constant for water, Kw. By the way, that's named after me, Kenneth White, Kw. If you believe that, I have a bridge downtown Chicago I can sell you. By the way, K is constant, W is for water. But I still like to say I was destined to be a chemist once I was named, because they already named a constant after me. How about that? See what a great chemist I am. Now, this is one of the most important things I can teach you. Kw equals the hydronium concentration times the hydroxide. And at 25 degrees C, room temperature, it's 1, or I should have really put 1.0 times 10 to the minus 14. And if you know, it's subtle, Monday. Know this. Yes, know this equation and know the value it's equal to. And I really should change know how to use this equation, the value it's equal to. Because on test number 4 in the final, I'll give you this right here. But if you don't know how to use it, well, you're lost. I don't want that to happen. Now, let's quick look at something. KW, my initials again. Equals this. Hydronium ion concentration times hydroxide, which is equal to 1.0 times 10 to the minus 14. And let's look at the Hi, everybody. My internet just died on me for a while, which is quite rare, but life happens. Luckily, I'll be able to splice the video from before which is converting now to the one I'm creating now. So let's get back to work. Everybody say a prayer to the computer gods that I don't lose internet again. For those who are non-religious, keep your fingers crossed. For those who are non-religious and don't believe in this, well, come up with something else that will help Dr. White have stable internet access. Bye, Diana. I'll have a nice vacation. All right, let's get back to work. Everybody with me so far? All right. I knew I should have made an offering to the gods, computer gods, but I didn't. But anyways, I was talking about KW, named after Dr. White, not really, which is the ionization constant of water, or dissociation constant of water, it's also called. And it's the hydronium ion concentration. Remember, brackets means moles per liter. Hydronium ion concentration, H3O plus, times the hydroxide equals 1.0 times 10 to the minus 14. Now, if you're given the hydroxide, how do you calculate the hydronium ion concentration? So what are we trying to find? This. What are we given? This. And how do we proceed? Well, we know this. At room temperature, and assume everything in this class will be at room temperature calculations, the hydronium ion concentration times the hydroxide equals 1.0 times 10 to the minus 14, which you haven't figured out is a very tiny number, but still this is very important. Well, I want to solve for hydronium. How do I get rid of hydroxide? You know this. Remember, anything divided by itself equals the number 1, cancels out. So I'm going to divide by hydroxide. Whatever you do to one side, you have to do to the other. There's a charge there, you just can't see it. That cancels out, and I'll rewrite this. Now I know the hydroxide ion concentration is this, 1.0 times 10 to the minus 4. So I'll put that in. And this equals 1.0 times 10 to the minus 10. How did Dr. White do that so quick? Well, let me teach you something. Whenever you have 10 to some power divided by 10 to some other power, that's equal to 10 times C minus D. So what I did was minus 14 minus minus 4. Now you can do this in your calculator, and that equals minus 10, which is how I did it so quick. So the answer to this problem is the hydronium ion concentration would be 1.0 times 10 to the minus 10. Now, as you know, Dr. White likes to share, especially when I have internet access, Gesundheit, whoever just sneezed. By the way, my grandmother trained me well. For those who have never heard Gesundheit, that's Yiddish for good health, or it's almost like saying God bless you, but it's in Yiddish. Gesundheit. And like I said, my grandmother, that was Grandma Greenman. What a great woman she was. Strong, powerful, great woman. I was so lucky to get to know her for many years. All right, let me share. Uh-oh. Dr. White is having a bad whiteboard day, sort of like bad hair days. All right, your turn. If the hydroxide ion concentration is 1.0 times 10 to the minus 10, then what? That's the WHAT. What is the hydronium ion concentration, H3O? And since I'm not asking you to memorize this, I'll give it to you. I'll give this an important information in test number 4 and the final. And go ahead and do it. Remember, KW is, I like to think, named after Dr. White. Didn't know I was such a great chemist. If you go in some towns, they've named streets after me. Kenneth Avenue. At least I like to believe that. Where I grew up in Lincolnwood, there was a Kenneth Avenue. We didn't live on it. And remember, when you're done, don't forget to give me a thumbs up. And for those who finish early, I give everybody time to finish. I see someone who's got an R in their name that I can't roll, has their video on. This and this just can't do that. I've given up. I've had a number of students try and get, I had one guy, what was it, spring semester, I think it was, not this last spring, the spring before, was it fall, one of those two, who really got upset with me because I couldn't roll the R in his name properly. And I apologized and I said, you better cool off because you don't want Dr. White upset at you. I'll be worse than I can't roll my R's. And he calmed down and he knew I tried, but I couldn't do any. But anyways, that's in the past. Let's go forward. Wow, was that a nice, smooth transition? All right, look out. Dr. White's in rare form. Okay, what are we trying to find? Well, hold on. We're trying to find the hydronium ion concentration. What are we given? The hydroxide is 1.0 times 10 to the minus 14. And what do we know? We know Kw, named after Dr. I love saying that, is equal to the hydronium ion concentration times the hydroxide equal to 1.0 times 10 to the minus 14. Running out of space, I'll move down here. This will be given to you, an important information, because it is important information. How do you solve for that? We've got to get rid of hydroxide. Remember, anything divided by itself equals 1, cancels out. So therefore, I'll divide this side by hydroxide. But whatever you do to one side, you have to do to both, the other side too. This cancels out because of this. I'm left with that equals this. Up here, we figured out, we were given what the hydroxide is. I'll put that in. And this is equal to 1.0 times 10 to the minus 10. And that's how you do. Oh, let's do one more. These are fun. Why don't you do this one? If the hydronium ion concentration is equal to 1.0 times 10 to the minus 18, then what is the hydroxide concentration? And like I said, this will be given to you. Kw, it always makes me smile, is equal to the hydronium ion concentration times the hydroxide ion concentration, which is equal at room temperature 1.0 times 10 to the minus 14. Uh-oh, I'm getting a sign my internet connection is unstable. Oh, it went away. So if I go away, hopefully I'll come back. Hold on, time to get my Lucky Charms out. Lucky Charm, Lucky Charm. I'll get the big one out. Really Lucky Charm. Hold on. It must have been the lucky sneeze. And when you're done, don't forget to give me a thumbs up. Isn't it interesting how Zoom doesn't have a thumbs down? Or some other emojis like What was one from childhood? Remember that? I'll do it again in slow motion. And don't forget, never let the little kid inside of you disappear. I haven't. It's one of the great joys of my life. He's still in there and active. And like I said, when you're done, give me a thumbs up or scratch your nose. I should send out Word document that you can print, that you can hold up the sign saying, I'm done. All right, I think everybody's done. Let's go ahead and do this. And what are we trying to find? We're trying to find the hydroxide ion concentration. What are we given? The hydronium ion concentration, H3O plus, equals 1.0 times 10 to the minus 8. I'm back again. For many years, I've had no trouble with wow. In the last 2 months, or the last couple of weeks, it's gone down more times than I have in the last 10 years using them. I don't know what's going on. Maybe their equipment is old and it's failing, or they've got some idiot who's new, who's pressing the wrong buttons. I don't know. Let me finish up the problem, then we'll take our break. Again, I apologize. Everybody send nasty emails to wow. I'm going to call them later today. What the heck is going on? All right. Everybody see the whiteboard now? We're trying to find hydroxide. We're given hydronium. We know this. We want to solve for this, so we got to get rid of this. We know anything divided by itself equals number one. That's how you get rid of it. So I'll divide this side by hydronium. That's H3O plus concentration. I better hurry up so I get this done before I lose internet again. I hope not. And whatever you do to one side, you have to do to the other side. And anything divided by itself becomes the number one. So I'm now left with hydroxide. I keep on wanting. Hydroxide equals 1.0 times 10 to the minus 14 divided by the hydronium ion concentration. And that is 1.0 times 10 to the minus 8, and that equals 1.0 times 10 to the minus 6. If I did my math right, remember 10 to the C, and you can do this in your calculator too. If you don't want to learn Dr. White's trick, and you learn this if you have to use a slide rule, is equal to 10 to the C minus D. In this case, it's minus 14 minus 8, which is equal to minus 6. Aren't you glad Dr. White was a math minor in college, undergrad? And that's how you do it. And let's take a break, a little bit late, come back at 11 o'clock. That's when the big hand is on the 12. For those of you who have digital watches, that's 11:00. And I'll see you in 5 minutes because I need to stretch and make an offering to the computer gods. See you in 5. right, haven't used this all day, so I can. I love that. Time to get back to work. All right, the next couple of things I'm going to cover are probably some of the most important things you will ever learn about chemistry. When I mean important, to your daily life. All right, so I showed you how using KW, the water ionization constant, W stands for water, not Dr. White, even though I like it too, but equals the hydronium times the hydroxide at room temperature 1.0 times 10 to the minus 14. Hold on a second while I save. Every time I lose internet, the video I've been recording is converted, and I got to save it or I'll lose it. I don't want to lose it. So hold on while Dr. White's doing important stuff. All right, let me make sure. Aren't you glad I know video editing software so I can put all the parts together? All right, now switch is on as high as I can turn it, and even beyond that. When we talk about acids and bases and solutions, especially we're talking about now aqueous solutions, which you know, but anyway, everybody see acid, base, neutral on the screen? Thank you. All right, now, there are terms that you should know. Ooh, let me get subtle. Ooh, 5 of them, that's a record. All right, first of all, what's an acidic solution? That's a solution in which the hydronium ion concentration is greater than the hydroxide. And this is called an acidic solution. If I can spell. Now, there's another thing you should know, and that's a basic solution. A basic solution is where you have the hydroxide concentration is higher than the hydronium. It's sometimes also called an alkaline solution. Where have I heard that before? Alkaline batteries. And that's where they get their name. And there, you should know, the hydroxide concentration is greater than the hydronium ion concentration. And we call that a basic solution. Now, what happens when those concentrations are equal? We'll have to wait till the next slide, and that's called a neutral solution. And a neutral solution is where the hydronium ion concentration equals the hydroxide ion concentration. So let's go back and review. You should know, acidic solution, the hydronium ion concentration is greater than the hydroxide, acidic solution. Basic solution, the hydroxide, OH minus, concentration, remember the little brackets here mean moles per liter, and you know that is concentration. Excuse me, getting all choked up over this good stuff. is greater than the hydronium ion concentration H3O+. And sometimes that's called alkaline solution. And finally, neutral solution. And that's where the hydronium concentration is equal to the hydroxide. And let's review this again. When something is acidic, the hydronium ion concentration, we're talking about solutions always. And we were talking about aqueous solutions. When it's acidic, the hydronium ion concentration is greater than the hydroxide. When it's basic, the hydroxide ion concentration is greater than the hydronium ion concentration. And finally, neutral. And that's when the hydronium is equal to the hydroxide. So acidic, hydronium ion concentration greater than the hydroxide. Basic, also called alkaline, hydroxide greater than hydronium. Neutral, hydronium equal to hydroxide. Now, if I said the hydronium ion concentration was 1.0 times 10 to the minus fifth, well, is that acidic, basic, or neutral? Well, you'd have to calculate hydroxide and then see which is greater, which is less. And that's a lot of work. And organic chemists especially, but chemists are lazy when we can. And someone came up with an easier way to remember this. And of all the things I can teach you, this is probably the most important concept this whole semester. What's that? And that is the pH concept. Really know this. And what's the pH concept? It's based on what's called the pH scale. And the pH scale is a small scale of small numbers that are used to specify the moles per liter, hydronium ion concentration, and this is important in an aqueous solution. And by definition, pH equal minus the log of the hydronium ion concentration. It's time for a special little Thanksgiving gift from Dr. White. Watch closely. Here's my special gift to you. If the hydronium ion concentration is 1.0 times 10 to the minus x, in other words, if I keep this always 1.0, which I will, then the pH is equal to x. And what I'm trying to say is pH, hold on, pH equal minus the log of the hydronium ion concentration equal, if hydronium ion concentration equal 1.0 times 10 to the minus x, therefore this is equal minus the log 1.0 times 10 to the minus x, and that's equal to x. So if I say, let me review this again. pH which is a scale, is equal to, by definition, minus the log. And logarithms are something, if you've had in math, you know about, but for my class, you don't have to know. That's part of my gift too. You don't have to use it on your calculator. The hydronium ion concentration. And if H3O plus hydronium ion concentration is equal to 1.0 times 10 to the minus X, then the pH is X. Well, let's practice this. And by the way, pH is always a small p, capital H. And 5 points. What is the pH of a solution if the hydronium ion concentration is 1.0 times 10 to the minus 10? And what are we trying to find? Oops. pH, what are we given? And an important information, test number 4 and the final, I will give you this. In the past, I made students memorize it. As you learn this semester, I've cut way down on memorization. So how do we do this? pH equal minus the log of the hydronium ion concentration equal minus the log, since we have it right here, of 1.0 times 10 to the minus 10, and that equals 10. Because remember, if you have minus the log of 1.0 times 10 to the minus x, that equals x. In this case, x is 10. It only works when this is 1.0, and I'll always do that on a test or final. Ooh, that was fun. Your turn. And I'll give you on test. Your turn. What is the pH of a solution if the hydronium ion concentration is 1.0 times 10 to the minus 5th? And when you're done, don't forget, give me a thumbs up. Or for those of you who know our gang, and you can see it on YouTube, it was a series originally in the movies about these little kids from the 1930s. And when I was a kid, it was always on TV, and they do the high sign like this. So if you're done, you can give me the high sign. See, even back then they had gang symbols or signs. It's our gang, the high sign. True story. Wow. See all the great things you're learning in chemistry class with Dr. White? Not only am I giving you chemistry, but I'm giving you life experience. I'm gonna have to charge extra for that. All right, anybody need more time? Going once, twice? All right, let's do it. What are we being asked to find? pH. What are we given? Hydronium ion concentration is this. What are we also given in important information? pH equals minus the log of the hydronium ion concentration, and that's minus the log, because we figured it out or found out that's that, 1.0 times 10 to the minus fifth. Remember, minus the log of 1.0 times 10 to the minus x equals x. In this case, minus x is 5. So the answer is 5. Oh, this is real fun. I want to do another one. And I can. And here we have what is the pH of a solution if hydroxide equals 1.0 times 10 to the minus fourth, 8 points. I'm going to do this one, then I'm going to let you try one because, you know, I like to share the fun. And here, what are we trying to find? pH. What are we given? What are we given in important information? Uh-oh, we got a problem here, folks. We don't have this number. What do we do? Well, remember, you're also given Kw equals the hydronium ion concentration times the hydroxide ion concentration equal 1.0 times 10 to the minus 14. So now we can go ahead. And this is one of those problems where you need 2 steps. And let's look at the 2 steps. In order to do the pH, you need hydronium ion concentration, H3O plus. So step 1, you have to solve for the hydronium ion concentration. And how do we do that? Hydronium ion concentration times hydroxide ion concentration equals 1.0 times 10 to the minus 14. You'll be given this in important information, test number 4 in the final. Remember, anything divided by itself equals 1 because they cancel out. So how do we get rid of this? Well, I'm going to divide that side by hydroxide. Now, anything you do to one side, you have to do to the other. This cancels out, as you see over there. And now we have oops, Got ahead of myself. It happens in my brain. It's like playing chess. You're always thinking a couple moves ahead. Well, when I lecture, I do that too, which I shouldn't, but I do. All right, now we know what hydroxide is. So I'll put it in, that concentration, and that's equal to 1.0 times 10 to the minus 10. Are we done? No, because we're trying to get pH. See, it even says here right on the screen. You know, things on the screen never lie. If you believe that, I got a bridge to sell you downtown. And now we have to do step number 2. Find the pH. And pH equals minus the log of the hydronium ion concentration equals, well, we found out hydronium is 1.0 times 10 to the minus 10. That's what we did up here. And remember, minus the log of 1.0 times 10 to the minus x equals x. In this case, x is 10, so that equals 10, and that's our answer. And that's how you do it. Let's go through this again. We're being asked to find the pH of a solution, and the hydroxide is equal to that. Well, we're trying to find the pH. We're given this. You're in important information, pH minus the log hydronium. Well, we weren't given that. We have to calculate it. So you have to do this in 2 steps. And remember, you're given Kw, first of all, pH minus the log of hydronium, that you'll be given. Kw, yay, that's me. I love this chapter because I get to use my initials all the time and dream about how I was such a great chemist, they named a constant after me. Uh-oh. I'm on an ego trip. Look out. No, I got to get off that ramp. But anyways, Kw equals hydronium ion concentration times hydroxide, which is 1.0 times 10 to the minus 14. This you will be given important information, test number 4 in the final. So step 1, solve for hydronium. How do we do that? Well, use this Kw equals hydronium times hydroxide, 1.0 times 10 to the minus 14. How do we get rid of hydroxide? Because we're solving for hydronium, divide the side. Whatever you do to one side, you have to do to the other. This cancels out. We're now left with the hydronium equals 1.0 times 10 to the minus 14 divided by the hydroxide equals this. Put in the hydroxide, you get the hydronium is 1.0 times 10 to the minus 10. Wrong number. Next, you have to do step 2, which is find pH. And pH is minus the log of the hydronium. We calculated this right there, so I'll put that in. And remember, minus log of 1.0 times 10 to the minus x is x. That's an awful looking x. That's still an awful looking x. Don't look. Oh, you looked. I see people peeking. That's better. X marks the spot. And when you calculate it, X is 10, so the pH is 10, and there's our answer. important information. I'll give you this. I'll also give you this, and Dr. White's smiling because I get to write my initials again. And it's your turn. Have fun. I was just thinking the video I'll make for today's lecture, when I splice the parts together, whenever I lost internet, I think I'll put a slide in there saying, oh no, lost internet access again, yuck. Is yuck a G-rated word? I think it is. By the way, Dr. White worked in shipping loading docks in college to make money during the summer, and being in chemical plants, I can swear in a couple different languages, including English, German, and Yiddish. Even though English is probably the best, you can pull off some good things in German and Yiddish too. For those who don't know what Yiddish is a mixture of Hebrew and German, spoke by Jews in Germany and also Jews in Poland and Russia. My grandparents spoke Yiddish, so I got to learn some. And the funny thing is, a lot of Yiddish words have secretly become commonplace in the English language. What do you call your rear end? A tush? That's Yiddish. If you've ever heard on a cooking show, they'll say, let's smear some butter or cream cheese on the spread or bagel. Smear is a Yiddish word. I can't tell you the nasty ones because that would be wrong in a G-rated class. Go to the internet, you can find them. I'll shut up so you can finish. This morning flew by quickly. Time flies fast when you're losing internet connection. Excuse me. And when you're done, give me a thumbs up. Oh, important announcement. I think I finished it yesterday or today, I forgot which. Go look in Blackboard, your grades. Pretty much up to date except for the lab that's done today. I went back, anybody who ended in things late, I've got your scores in there. If you're missing something, check with me. I probably either couldn't open it or you didn't upload it yet. If it's where you can't, send it to me in the email. And don't forget, work on your extra credit project. If you want, email me it before it's due. I'll check it and tell you what's wrong so you can correct it, and you can get getting all choked up over this again. And you can get 10 bonus points. All right, let's go ahead and do this. So I think everybody's done. What are we being asked to find? pH. What are we given? Ooh, got the minus sign there. And important information, you'll be given pH equals this, Kw equals this. Now, you need 2 steps. Step 1, solve for hydronium ion concentration, because you need that to calculate the pH. So how do we do that? Hydronium ion concentration times hydroxide ion concentration equal 1.0 times 10 to the minus 14. I want to solve for this. I got to get rid of the hydroxide. Remember, anything divided by itself equals the number 1. Whatever I do to one side, I have to do to the other. Remember, if I'm going too fast, you can always go back and look at the video. Yay. And anything divided by itself cancels out. I now have this. I know hydroxide is this number, so I can put it in. And I know this is equal to 1.0 times 10 to the minus 3. Am I done? No, I'm trying to find pH, and this is not the pH, but I now can do step number 2. Find or solve for pH. And here pH equal minus the log of the hydronium ion concentration, which we just found out was this number. So I'm going to put it in. And remember, minus the log of 1.0 times 10 to the minus x equals x. In this case, x is 3, so this is equal to 3. And our pH equals 3. And that's our answer. I see people are copying this down, so I'll wait. Good news, I have plenty of practice problems for this chapter. When you're done writing, give me the high sign or something. I think everybody's done writing. Now the question is, all right, well now we can find pH. What good is it? And that's a question you should always ask when you're learning stuff. What good is this? Well, it turns out a lot of good. And of all the things I can teach you, the following is the most important this semester. Oh, it even says it on the slide. Can everybody see important on the screen now? Give me a thumbs up if you can. You see important on this? All right. First of all, pH is a range from 0 to 14. Never less than 0, never greater than 14. Now, the lower the pH, the more acidic the solution is. And the higher the pH, the more basic the solution is. And this is a logarithmic scale. I'll explain that. Now, let me, wrong thing. This will not be in important information, but you should know this. This is one of the most important things. pH scale, 0 to 14. In the middle is 7. Remember I talked about acidic, neutral, and basic solutions? When the pH is less than 7, it's acidic. When the pH is 7, this is neutral. When the pH is greater than 7, the solution is basic. And now all I have to remember is this scale right here. And that tells me everything I want to know about acidic, neutral, and basic solutions. Now, guess what? In your stomach, the liquids in there, your stomach fluids are acidic. Why? Because there's an acid present. In your stomach, is HCl, hydrochloric acid, and it's acidic because there's an acid in your stomach. And that helps break down food. If you took my organic chemistry when I used to teach it here, or my 170 that I'll be teaching at Elgin Community College online next semester, you'd learn how this actually breaks down your carbohydrates or your proteins or your fats and oils, because I teach that. So you should know. Probably one of the most important things, if not the most important thing, I'll teach you. pH scale goes from 0 to 14. Below 7 is acidic. At 7 is neutral. Above 7 is basic. Everybody see the cute little thing on the screen with pH scale? With the different things like bleach, milk, tomato juice. Can you see that? All right, I'm glad I asked. Let's try this again. Now can you see it? All right. Now, this is the pH scale. And I just wanted to show you. Notice it says gastric acid, as your stomach acid, is pH 1, which is less than 7, and it's acidic. Now, lemons and limes are acidic because they contain an acid, and that acid is citric acid, which I won't teach you the structure, but citric acid is a weak acid. And how many of you have ever bit into a lemon and you go, ooh, is that sour? And acids cause things to taste sour. And how many of you ever bit into a lime? Like after you do tequila shots. But anyways, I didn't say that. I won't tell you the story about tequila and Dr. White in Guadalajara. True story, but I can't tell you that story. That was, wow, good memory. But anyways, limes have less acetic acid, or no, citric acid than lemons. That's why they're less tart or sour, but they still have a punch to it. Tomatoes and tomato juice and ketchup are acidic. How many of you ever had canker sores and you put your french fries in ketchup and eat it, and then your inside of your mouth burns a little? That's because, again, citric acid in the tomatoes. And if you look at pure water, and you do not have pure water coming out of your tap, this is something I can't get my hands, and you have to do what's called distilled, steam distilled water. The pH is 7. Now, baking powder, soda, sodium bicarbonate, a weak base, and that's pH 9. And the higher you get to 14, the stronger it is. Ammonia is about 11 in water. And where they say concentrated alkali, solutions of alkali, they're talking about solutions of sodium potassium hydroxide, strong base, pH of 14. And you should know above 7 is basic, below 7 acidic, at 7 neutral. Now, for those of you who are interested, your blood, notice I was working outside doing cleanup work and get my outside ready for the winter. By the way, my back's back to 95% good, thank God. Thank you. But anyways, and also thank the PT physical therapist at NCH Group. They're great people. But anyways, your blood, everybody see my blood vessel? Let's see, it's easier to see it right there. The pH of your blood is very important. It's a very narrow range. It's kept that way by a Chandler's principle. And if the pH of your blood gets out of this very small range, you die. And your body has a way of regulating this. How many of you have ever heard of the problem called acidosis? And that's when your pH, your blood goes too low, acidic, and it will kill you. It was a great part of the movie Andromeda Strain, the first one from the 1960s, not the remake, which was, but it's a great movie. You should see it. Now, I got time. True story. When I was working at AkzoNobel and I was the section head of a major research development group, I had a number of other PhDs, masters, chemists, and other technicians reporting to me. And I had this one chemist who had a master's degree, came in with me with a report. And any reports I always proofed and signed off on before they were distributed throughout the whole company. That was part of a section head's job. Also, you didn't want somebody putting out garbage because you'd get fired possibly too. So the guy gave me a report and he measured some important pHs. And I said, all right, I'll read it. And I went and started reading it. And I saw the pH he had down there for some of them were like 15 and 16. pH can only go from 0 to 14, only. So I called him back in my office and he sat down. I said, do you want to get fired? He got shocked. And I was not happy, and which is why I said that. I said, here's this report, and gave back to him. You know the pH scales from 0 to 14. There's a meter you use to measure, and it wasn't obviously calibrated properly. Make sure you calibrate your pH meter and go back and redo this, or otherwise you won't be working here again. I was really upset that someone was so stupid at that level that they didn't know pH goes from 0 to 14. And that's a true story. And that person learned the dark side of Dr. White, which I try and hide. But at that point, I was pretty polite because I didn't even use profanity or anything like that. I kept it level and I didn't even scream at him. By the way, the important thing, when you're managing people, screaming at them and also doing personal attacks, just destroy the relationship and never get what you want. I learned that the hard way when I first started managing, and I learned that lesson many decades ago. All right, looking at the clock, I think we're just about out of time. I'm still got internet. Now, speaking about running out of time, we're almost at the end of the semester. I got to sneak in, if not next week, the next week after, at the end of one of our lectures, I'm going to do a very, very, very special gift to you. It will be optional, and I won't put it in the video. And if you can't make it, come to my office hours, and that is I will teach you all how to interview. Most of you don't know how to interview. What I mean by interview is if you're trying to get into school like nursing, you have to go in for an interview. If you're trying to get a job, you have to interview. And Dr. White has hired people. And I'll teach you some skills that will put you far and above the other candidates. And I've done that for a number of years to my Chem 112, that's the other school, Chem 1211, and also Chem 1212 when I taught it. And it's worked quite well for those students. So with that, I'm going to look at the clock. I went a minute over, but I also lost time from the internet. And with that, I'm going to say, Gehen gesund, goodbye. I'll see you tomorrow. Remember, tomorrow I'll go through the equilibrium problem set. And bye. Have a great rest of the Monday on our special Thanksgiving week Monday lecture. I was almost going to do, who did that? The Cisco kid used to say, hasta la vista. For those of you who don't know, the Cisco Kid was a great TV show when I was a kid. And his sidekick was named Pancho. That was almost as good as the Lone Ranger. And he had the most amazing sombrero. It had silver embroidery. It was also, his clothes were, looks like he was going to a wedding his own. With that, Gehen gesund, be healthy. I'll see you tomorrow. Bye. I still hard. Bye. Signing off from COD North.